Alright, we're going to start out by going over scientific notation and sig figs. And then this was done by Connor, Grace, Evan, and Marcus. So for scientific notation, it's used for the abbreviation of big numbers. So if we had a number such as 576 million, how would we get that into a smaller number? We would have to convert it. Alright, here, and start with the decimal and then go over until you have 1 right there. And then you count the amount of troughs that you have, and it's to the 8, and that is why it'd be 5.76 times 10 to the 8th. And then for another one, a number that's smaller, we would have to do the same, but work backwards this time. So starting with the decimal, right, there's your new decimal, and that was 6 troughs. So you have 6.54 times 10 to the negative 6. Pretty simple. Alright, rule number 1 for sig figs. Non-zero digits and zeros between non-zero digits are always significant. So for an example, how many sig figs are in 220.1? So what we're going to do here is count the amount of numbers. So that would be significant, that would be significant, and because it's 0 in between, it's significant, and that's significant. So there's going to be 4 sig figs. For the next example, we're going to have to do the same thing, count the amount of significant numbers, significant, the zeros in between, significant, and that is significant. So it's going to be 3.
Alright, I'm going to talk about rule number 2 of sig figs. Leading zeros are not significant, and so let's look at these examples. How many sig figs are in 0.1? Well, we just said that leading zeros aren't significant, so these two do not matter, so there's only one significant figure. The next one, how many significant figures are in 0.104? Well, this one doesn't matter, like we just said, so 3 is the answer. Alright, rule number 3. Let's see what this rule is. Zeros to the right of all non-zero digits are only significant if a decimal point is shown. So here's our example. How many sig figs are in this one? I'm gonna go ahead and say 1, and that's what it is. Yeah, the same one. We're gonna have all zeros to the right. So all these are significant because there's a decimal point. So 4.
So, rule number 4 of sig figs. For values written in scientific notation, the numbers at the beginning are significant. So an example for that is, how many sig figs are in 5.5 times 10 to the second? Okay, so here we go. So here's 1, 2. So there's 2 in that one. How many are in 8.499 times 10 to the third? 1, 2, 3, 4. Yeah, we're just going to go on that one. So adding with sig figs, you need to end with at least number of decimal places. So that means the part after the decimal places, those are only the sig figs that you're going to be counting. So Billy had 49.3 grams of apples. His sister added 22.945 grams of apples. How many grams of apples with the correct significant figures does Billy have? 49.3 plus 22.945, simple addition. So, and you see that there's only 1 decimal place right here, and there's 3 right here, and you want to go with your least. So you would have 2 sig figs. You would simplify it down. So subtracting with sig figs. ending with the least number of decimal places, just like adding. So let's get an example. Kramer has 100.7 grams of hair on his head, but lost 43 grams due to a bad haircut. How many grams of hair with correct significant figures is left on his head? 100.7 minus 43. And you see that you have 1 right here, and then none right here. So, with correct sig figs, you would round it according to that.
Alright guys, this is Grace, and I'm going to talk to you about multiplying and dividing with sig figs. So basically, you're just going to end with the least number of significant figures. For an example, Jerry's doing his taxes and has to do the following equation, 2 times 10.09, and you're going to do the answer with correct sig figs. So basically, when you do multiply those two, you're going to get 20.18, and if you're looking at this number, it only has 1. This one has 1, 2, 3, 4. And you're going to and you notice that this one has a least, so you're going to have to get rid of these 3 numbers, and you're going to end with 20. Now with dividing, it's just the same rule. You're just going to end with the least number of sig figs. And here's an example. Newman has 4.5 pieces of pie and wants to divide it between himself and George. How much pie with his correct figs will each person get? So you're just going to do 4.5 divided by 2. And if you notice, this one has 1, 2, and this one has 1 sig fig. So what you're going to do is you're going to end up with 1 sig fig for your answer, so you round according to this guy. And since it's below 5, you're just going to leave it at 2, so your correct answer is 2.
In a common logarithm, there are as many decimals after the decimal point as there are significant figures in the original number. So here's an example. Log of 217 is 2.336. So you see you have 1, 2, 3 sig figs over here in the original number, and after the decimal point you'll have 1, 2, 3, because that's how many you had in your first original number. The extended number is actually 2.33, so yeah, y'all can read. But using correct sig figs, which is 3 numbers in the original, 3 significant figures in the original, so there would be 3 after the decimal.